Introduction to IAM. AWS Identity and Access Management, IAM, the secure and flexible system that controls user access to AWS resources. It allows you to manage who can access your AWS account and what actions they are authorized to perform, making it central to securing AWS infrastructure. Here's a breakdown of key aspects.
1. Users. IAM users represent individuals who need access to AWS resources, like developers or administrators. Each user can be assigned specific permissions and can have individual login credentials for AWS Management Console or programmatic access via access keys.
2. Groups. IAM groups are collections of IAM users with similar permissions. Assigning policies to groups rather than individual users can simplify permission management, for example, creating an admin group with elevated permissions or a read-only group with limited access. 3. Roles. IAM roles are similar to users but intended for granting permissions to entities that don't have AWS accounts, like applications or AWS services. Roles are commonly used to allow an EC to instance or a Lambda function to interact with other AWS services securely. 4. Policies. IAM policies define permissions, specifying what actions are allowed or denied on which AWS resources. Policies are written in JSON and can be attached to users, groups, or roles. AWS provides managed policies, but custom policies can also be created for fine-grained control. 5. Permission boundaries. These are advanced settings that act as maximum permission limits for IAM roles or users. A permission boundary sets the outermost limit of access a user or role can be granted, which can be helpful in large organizations where multiple administrators manage permissions. 6. Multi-factor authentication MFA. MFA provides an additional layer of security by requiring users to provide a second form of authentication, such as a code from an authenticator app, in addition to their password. 7. Best practices. Use the principle of least privilege. Grant only the permissions necessary to perform a task. Enable MFA for users with high-level permissions. Monitor IAM activity. Use AWS CloudTrail to track IAM changes and user actions. Regularly review and rotate access keys to minimize security risks. Example use cases. Granting temporary access. Assign an IAM role with temporary permissions for users or services that only need access for a limited time. Cross-account access. Use IAM roles to allow users from one AWS account to access resources in another account securely. Why IAM matters. IAM is essential for maintaining security, compliance, and efficient access management. By controlling access effectively, you can protect sensitive data, manage resource usage, and streamline administrative tasks within your AWS environment. AWS Elastic Compute Cloud EC2, a web service that provides scalable, resizable compute capacity in the cloud, allowing users to run virtual servers referred to as instances for various applications. EC2 provides flexible, reliable, and secure cloud infrastructure, enabling users to launch applications quickly without needing to invest in physical hardware. 1. Instances. Virtual servers. EC2 instances are virtual machines that run applications in the AWS cloud. Users can select from various instance types optimized for different tasks. Example: compute intensive, memory optimized, storage optimized. Instances can be scaled up or down to match application demands, providing flexibility in resource management. 2. Instance types. EC2 offers a wide variety of instance types designed for different workloads. General purpose. Example: T3, M5 for balanced CPU and memory. Compute optimized. Example: C5 for CPU-bound applications. Memory optimized. Example: R5, X1 for memory-intensive applications. Storage optimized. Example: I3, D2 for applications requiring high storage IOPS. Accelerated computing. Example: P4, G4 for GPU-based tasks like machine learning or graphics processing. 3. Storage options. Elastic Block Store EBS provides persistent block storage for EC to instances. EBS volumes are durable and can be attached, detached from instances. Instance Store. Temporary storage directly attached to the instance. Data persists only for the instance's lifespan. Amazon S3. Object storage that can be accessed from EC2 for larger, unstructured data storage needs. 4. IME Amazon Machine Image. An IME is a pre-configured template that defines the operating system, application server, and applications for the EC to instance. Users can choose from a wide range of AMIs or create custom AMIs based on their specific configurations and software requirements. 5. Security. Security groups act as virtual firewalls, allowing or denying inbound and outbound traffic based on defined rules. Key pairs, used to encrypt and securely connect to Linux, Windows EC to instances via SSH, RDP, IAM roles, can be assigned to instances, allowing them to securely interact with other AWS services. 6. Networking. Elastic IPS. Static IP addresses associated with instances for consistent access. VPC Virtual Private Cloud. Each EC to instance is launched within a VPC, which provides network isolation. Subnets. Organize instances within VPCs into public and private segments. 7. Pricing models. On demand, pay per hour or second. Flexible, but higher cost for short-term needs. Reserved instances offer discounts for long-term commitments, 1 or 3-year terms. Spot instances allow you to bid for unused egg to capacity at reduced rates. Cost-effective, but can be terminated if capacity is needed elsewhere. Savings plans. Commit to a consistent usage level for discounts without being locked to specific instance types. 8. Elastic Load Balancer ELB. ELB distributes incoming application traffic across multiple instances to improve fault tolerance and ensure high availability. 9. Auto-scaling. Auto-scaling automatically adjusts the number of instances in response to demand changes, enabling seamless scaling up or down. Example use cases for EG2. Web hosting. EC2 can host websites and web applications, scaling resources up or down as traffic changes. Big data processing. Run data analytics tasks on EC2 with the appropriate instance types. Machine learning. Utilize GPU-powered instances for model training and inference. Benefits of EC2. Scalability. Adjust resources based on demand. Cost-effective. Choose from flexible pricing options and only pay for what you use. Customizable. Select instance types, storage, networking, and security options to fit your needs. Global reach. Deploy instances in multiple AWS regions worldwide. Thank you.